Okay, so this is the TLC plate after it's been run for, how long has it been, you guys? 10, 15 minutes maybe? 10 minutes? It doesn't take that long, actually. So as soon as I took it out of the chamber, I marked how far or how high up the solvent front went, how high up the solution went, and it went as high up as where the mark is. So this is where I started, and this is where it ended. Sounds good? That's important, because I have to record that distance. So I'm gonna take my ruler. Everybody's got their lab manual with them? All right, good. It is 75 millimeters. We're going to page number 78. You see where it says solvent front, millimeters moved, 75. Solvent front, millimeters moved. It's gonna be 75. Don't worry, we'll give you the numbers. Okay? Now, the next thing I'm gonna do, again, I hate picking this thing up. I'm gonna mark the pigments. Here's one pigment. You see that? That's the carotene. You see? And I'm gonna mark the other ones. Let me just mark them and show you. Here are the other ones. Where the pencil is, look right next door to it. That's where the pigment is. You notice they have different colors, right? So does everybody see it? So we're only dealing with 4 of them. Good? Everybody see it? All right. Now what we're going to do is measure the distance of each one. So the next number that you write in your table is right underneath the 75. You're going to record 68 millimeters. Right underneath the 75, you're going to record 68. And then I measure the next one. See, I'm measuring the distance the pigment traveled from the line where they started. You see that? The next one is going to be 25 millimeters. Good. The next one is going to be 22 millimeters. And the last one, 11 millimeters. Good. So let me see this here so I can put it on the video so you can have the numbers. 75, 68, 25, 22, 11. Now, on this side of this, on the column here where it says color, we have to pick up the colors from the plate. The top one is going to be yellow-orange. Now, look, they put a dash here. You don't put anything in it. It's where you see where the 68 is? On that line, the 68, the color of the band that produced the 68 millimeters is going to be yellow-orange. Just use this one. Yellow-orange is that one. Okay, the next one is going to be the blue-green. Blue-green is the next one. All right, so yellow-orange, blue-green, and then the next one is going to be yellow-green, yellow-green. And the last one is just the yellow. So your job now, you got these numbers here, and you got the colors here. Your job is to calculate what is called the RF. It's so easy to do. The RF is the distance of the pigment traveled divided by the solvent front. So for the first one, it would be 68 divided by 75. Let me do it again. The distance of the solvent, the fragment traveled, your first one traveled 68. divided by the distance of the solvent front, how far the solvent moved. And yours was 75. So that one is 68 divided by 75.
0.91.
You'll figure it out with the calculator, right? What's the next one? What's the setup for the next one? 25 divided by 75. What's the setup for the next one? 22 divided by 75. What about the last one? 11 divided by 75. Your next task at home to do is to figure out which pigment is which. Well, you can go based on the color, because you have a key right here on page 77. It tells you which color matches with which pigment. But before we finish this here, I have a question for you. What is 75 divided by 75? It's 1. What that means is this. See, you got to understand what this RF value means. If the pigment is traveling with the solvent, then the distance of the solvent is going to be 75, and the distance of the pigment will also be 75. Do you see what I mean? Then you're going to be 75 divided by 75. You're going to get 1. An RF of 1 means that the pigment is running with the solvent. That means it's not sticking on the plate. Do you see what I mean? Not even a little bit. That means it's not polar. Am I right? See, we gotta bring it all the way back to what we're talking about in the beginning. We said that if the pigment is polar, it sticks onto the plate. You'll have a hard time moving it. That means it'll stay on the bottom. It'll be closer to the line that you drew than the mark that you made at the top. But if the pigment is hanging on a little bit, then it'll move slower. But if it's not hanging on at all, then it'll be where the solvent front is, or very little. So the closer you are to 1, the closer you are to the solvent front. That means you're not polar, or you're very little bit polar. So you guys tell me, the band on the bottom right here has high polarity or low polarity? High polarity. Very good. Because it's sticking on the plate and the solvent is having a hard time moving it. The carotene band would have what? See? Lower polarity. That's the take-home message. In a couple of weeks or so, I don't know how many more weeks we have left for the semester here. Maybe 4 more weeks or 5 more, I don't know. I have on my lab exam review questions, you know, the Kahoot. I have one of these questions on there. And it will ask you about the RF value. And you'll see how many students will still get it wrong. And prove me wrong. For whatever reason, once we finish this lab, students forget that we even did this. I can throw this plate on an exam and give you all the numbers and ask you, calculate the RF. And then follow up and say, what does the RF mean? What does that number mean? Well, the closer you are to 1, the more you're moving with the solvent. That means the less polar you are. You're not sticking to the plate. The closer you are to 0 means you're sitting down here. That means you're really hanging on to that plate because you're polar. So when you calculate these, your carotene may end up being 0.9, which is very close to 1. The yellow band at the bottom, yellow pigment there, xanthophile, is going to be maybe like 0.3. So it looks like you can tell now from the RF value which one is more polar than the other. Thank you, sir.